Hello everyone, and welcome to the first tutorial on unrolling meshes with Ivy for Grasshopper. In this tutorial I'm just going to do a simple walkthrough on how to unroll a mesh in just a few simple steps with the tools that come with Ivy for Grasshopper. First of all, we are just going to bring in the mesh in the Grasshopper environment. For this I'm just going to get a mesh component, and I'm going to instantiate the mesh from Rhino. Set one mesh. I'm just going to hide the geometry from Rhino so we can see just the geometry, the preview geometry from Grasshopper. The next step is to create a graph from this mesh using the standard components that come with Ivy. For this I'm going to use graph from mesh. This you can find in the tab create graph. I'm just gonna plug in the mesh into the create graph, and already you can see the graph preview that appeared on the mesh. I'm just going to hide the preview of the mesh so you can see the graph better. The next step is to add weight to the graph so we can use this property of the graph to create a tree and then to perform the unroll. For the adding of the weight, I'm going to use a component from the third tab, weight graph. The component is going to be face angle edge weight. Just going to connect the component into the graph from mesh component. I'm going to hide this component so as we can see the preview from the add weight, and this is important because I'm going to show you a setting that comes with all of the components from Ivy that are showing graph previews. You can right click on the component and select enhance preview, and then you can see a different preview of the graph on the original geometry of the mesh. Here you can see the edges of the graph shown with different thickness. This thickness is based on the angle between the faces of the mesh, and the bigger the angle between the faces, the thicker you can see the edges of the graph. Okay. The next step is to create a tree from the graph that we just created on top of the mesh of the rabbit. For this I'm going to use a component from the tree graph section. I'm going to use MST Kruskal. This is an algorithm that creates a tree based on the mesh of the rabbit. I'm just plugging in the data into the component. I'm hiding the add weight component, and I'm just doing this so we can visualize better the preview from the create tree component. I'm just going to do the same and click on the enhance preview, and you can see that the create tree component has a different preview. In the sense that the thickness of the edges of the graph now depends on the topological distance between those edges and the nodes of the graph to the leaves of the graph, which are the extremities you can see here on the mesh. So as the tree kind of engulfs the mesh, some of the nodes are end nodes of the graph, and those are called leaves. So each of the edges of the graph that plug directly into those nodes are going to be the thinnest, and the edges that are going to be the deepest inside the graph are going to be the thickest here in this preview. This is important because it gives you already a sense of how this unroll operation is going to be performed, because the unroll is going to start from the leaves and it's going to continue towards the thickest branches in the tree until it reaches the root of the tree. Okay, the next step would be to plug in this tree graph component into the actual component that's going to do the unroll, which is the mesh graph unroll component. So basically the only thing we need to do to get the unrolled version is to plug in the graph into this M component here, into the M input of the component, and all of a sudden we can see the result laying here on the XY plane. The only problem is that our result is a little bit, the pieces are a little bit jammed together, and you can hardly see what's going on here. In order to space the pieces a little bit, we are going to plug in a slider in the last input of the component, in the T input here, and that this is going to tell the component the amount of distance that the pieces are going to have in between them. So I'm just going to plug in a slider that's going to say maximum 30, and 30 it's going to be the distance, or something close to 30, or maybe a little bit lower, is going to be the distance that we are going to use to visualize the pieces here. For now, as you can see, we are just seeing the contour of the pieces, actually the contour of each of the faces, and there is no additional geometry that guides us in putting the pieces together, and no text tags to show us how these pieces are going to be brought together so they will form the original geometry. But this is just a few steps away, and first of all, in order to see the glue flaps that are going to be used to bring the flat pieces together, I'm just going to plug in another slider, this time in the F input of the unroll component. I'm just going to plug the default value for now, and all of a sudden you see that the flaps have appeared on the sides of the flat pieces. Now you may see that not all of the sides of the pieces, not all of the edges of the flat pieces have glue flaps on them. That is because the component is thought in such a way that the flaps are only on one side of each of the edges that are going to be seams in the final geometry. So you will see later on that each of the edges that is located on the outer parts of the flat pieces is going to have a flap. So each of them is going to be connectable to its respective neighbor. Okay, so now that we have a reasonable geometry, we will need something to tell us which of the curves that we actually have here laid out in front of us we are going to cut, which we are going to fold, and in what direction. And for this we will have to take a look at the outputs of the component. So by default the component exposes all of the curves that are needed say to fabricate the flat pieces, but there is no distinction in between them. So in order to have a clear distinction, I'm going to hide the component itself, and I'm going to use a bunch of curve containers which I'm going to plug into the different outputs from the unroll component. The first one is going to be C. The C stands from the cut lines, and as the name says, those are the lines that are going to be cut in order to have the final pieces in their final laid out shape, ready to be folded. Those are just the lines that we are going to cut. The next lines that we are going to deal with are the fold in lines, The fold-in lines are lines that are not going to be cut, but instead they are going to be folded. And exactly as the name says, they are going to be fold-ins. So the pieces, the flat pieces are going to be folded in on right along those lines. This means that those lines are going to be considered in this case valleys. The next curve component is going to be plugged into the FO output, which means fold out, and this is going to be those are going to be the so-called mountain folds. Okay, so we have curves, we have the cuts, curves, we have the fold ins, and we have the fold outs, and the next one it's called flat lines. If I'm going to plug in another curve here, I'm going to get some sort of a strange warning, because in our case we have no flat lines coming out of this mesh. There are no faces that are perfectly aligned with a zero angle, or like a perfect flat angle in between them. So there are no flat lines to be seen here. So that's why this component does not output anything. The next output we have text, and the next after that we have placeholders. Those two components, those two outputs work closely together, because they will be used to create the text tags that are going to be very useful in putting this whole thing together. To create those text tags, we are going to use the classic text tag 3D Grasshopper component, and we are going to make just a few adjustments before plugging in the data from the unroll component. I'm just going to use the different justification here. I'm going to use middle center, and I'm going to use a slider, a number slider, and I'm going to lower the value, and I'm going to plug in this slider into the size of the tags, and then I'm going to use the text into the text, and the placeholders into the location of the tag. Now you see that something has appeared here, and we already have a bunch of letters and numbers that are showing up on our flat pieces. We have no idea what they mean for now, but I'm going to explain it in a second. And first of all, I'm just gonna lower the size a little bit so they become a little bit more uncluttered, let's say. So what about the numbers and the letters? So you'll see that each of the faces that are located in the laid out flat pieces has one tag in the middle of it, and has at least one tag on one side. Some of them have more than one side with a tag on them. So you will see that the numbers on in the middle, they are describing the actual, let's call, name or number of the face of the mesh that this particular part of the piece, of the laid out piece, refers to. So for instance, this particular piece stands for G0, which means is the graph 0. Since we have only one graph here, everything is going to start with G0. And then we have a number 3, and then we have 199. So number 3 means that we are looking at the piece number 3, which, I mean, according to the Grasshopper numbering system, is actually the fourth piece in the whole series. And then we are looking at face number 199. This number 199 refers to the face number on the original mesh that we unroll. So we have graph 0, piece number 3, face number 199. This means that this is going to be on the edge of some other piece in another part of this series of flat pieces, where that respective piece is going to connect, and that respective piece is going to connect to this one via its edges. And that piece is going, we can actually find it right now because it's a piece called G01551. So we have to look at a different piece that's called piece number 15, and we have to look at face number 51. And there we will find, probably on the side, we will find this inscription there that says 3199. So 1551, and we have to find 3199. 1551. It's gonna be somewhere, I don't know, let's look from the top because it's easier. So 1551. 1551. Actually, piece 15 is quite big, but we will find 1551 is going to be easy, I'm sure. Okay, 1551. Oh, there it is. 1551, and we have G03199, exactly as you saw on the other graph. This is the piece that is going to be glued to that one using the flap. The flap is actually on the other piece, you have already seen it. Okay, so we have the tags, they seem to be working, and we have the curves laid out, and we have the most important part, all the curves are distinguishable one from the other, and we can select just the cut curves, the fold-ins, the fold-outs, or if we had any, the flat curves. We have now all the information in order to actually cut those pieces and then fold them into the shape that is going to be the exact representation, physical representation of the mesh that we unrolled. There's another little bit of information that's being produced inside this unroll component, and you can find that into the SF and SM outputs. SF means split flat graphs, and SM means split mesh graphs, and exactly as their name says, they are outputting a series of graphs. First one outputs a series of graphs that look exactly as the flat pieces, and I'm just going to demonstrate this by connecting a graph parameter. And as you see, a series of graphs have populated the inside of those flat pieces, and I'm going to switch back to perspective view just so we can see better what's going on. And I'm going to hide all of the previews of the original graphs that we have unrolled, and I'm going to connect another one of these components, another one of these parameters, to the SM component, and we're going to have all the pieces from those unrolled pieces. We're going to have them first of all we're going to have them unrolled here on the ground plane, and then we are going to have them in the original position but split exactly like the pieces on the ground on the original mesh. And in order to see this a little bit more clearly, I'm going to hide those graphs here, and I'm going to use two mesh components, and I'm going to connect them into these corresponding graphs. By connecting a mesh component into one of the outputs of a graph component, this is going to be an automatic casting from a graph to a mesh, and we can use now the mesh just like we would use a visualization component to extract a mesh from a graph. So in order to visualize and get a feel on how the pieces are going to the flat pieces are going to be found on the original mesh, I'm going to use from inputs here from the parameters section of Grasshopper a color wheel component, and I'm going to use this color wheel to give separate colors to each of the pieces. For this I'm going to use a list length component. I'm going to connect one of the mesh lists here, and then I'm going to connect this into the color wheel, and I'm going to use two custom preview components, and those custom preview components I'm going to connect to the color wheel, and to the color wheel, and then I'm going to connect the geometry there, and I'm going to connect the geometry here. Okay, and now I'm just going to hide those two mesh components so we don't have any problems with them, and voila, we have first of all the same colors on the pieces on the ground and the same colors on the pieces that are on the original mesh, on the rabbit in our case. If you want to have the colors a little bit more varied, or you can just fiddle around here with the mesh, with the color wheel, and then you get the colors you get the different colors a lot more visible, so you can see where each of the flat pieces kind of relates on the original mesh. So this is it. That's how you get the unroll information from the mesh using Ivy. All that's left right now is to bake this information somehow back into Rhino, print it out, or use a CNC cutter to get your pieces cut, and then fold them out and glue them back together to have your object created from the material of your choice. That's it. I hope you enjoyed this, and stay tuned for new tutorials regarding Ivy, and I will try to show you how to use custom weights to guide the unroll process, or use the tree system and the graphs to partition the meshes into logical parts. See you soon.